Okay, here we have a polar coordinate question, and we're trying to work out the area that is shaded. Now, how we're going to do this is we've got two equations. We've got r equals 3 sine theta and r equals 1 plus sine theta, and we can see that they intersect at two different points. So just for a start, okay, I'm just going to draw two lines like so. Actually, before I even do that, let's just draw the axes, because we don't have an axis on this. It'll just make it a bit more easier to imagine what's going on. And the base axis actually starts from here on this question. Okay, and if I just connect it like so, we can see that. And we also have like this line of symmetry down the middle, so that let's keep that in mind, so that might come in handy later on. Okay, so we've got these 2 points of intersection here and here. So we want to try work out a value for theta that that is the same. No, we want to try work out two values of theta. Sorry. So let's do that by just equating them together. So we end up with 1 plus sine theta is equal to 3 sine theta. 1 is equal to 2 sine theta. A half is equal to sine theta. Now we're working in radians. Polar coordinates are generally radians. I've never actually seen degrees, I'm going to be honest. No, they're always radians. And then if we to the minus a half, theta is equal to pi over 6. And we can also use symmetry or however you like to use. But we also have another value, 5 pi over 6. So here, theta will equal to pi over 6 is equal to pi over 6 and 5 pi over 6, like so. Now, how do I know that this isn't 5 pi over 6? Because at the beginning this is going to be 0, and then it goes all the way around, and that's 2 pi. Here this is going to be pi over 2, that's going to be pi, that's going to be 3 pi over 2, and so on. So, but technically that's 0. Okay. That 0 shouldn't really be there. Alright, let's see what else we have. So what we can do, we can work out the integral between these two limits, pi over 6 and 5 pi over 6, of this section. Okay, now that section is going to be part of this. Okay, it's going to be part of that equation. So you have the integral of pi over 6. Actually, but let's look at the formula as well. It's going to be r is equal to well, the integral is 1/2 r squared d theta. This is from your formula book in Edexcel, but this is the formula generally for when you're trying to do the polar coordinates integration. So 1/2 integral of r squared theta. We know that r is equal to 1 plus sine theta. Okay, and we're going to be integrating between those two limits. So I'm just going to expand this out. R squared is actually going to equal to sine squared theta plus 2 sine theta plus 1, and I want the integral of that. Let's put that as a second line because I want a half as well, right? So I want sine squared theta plus 2 sine theta plus 1, and I want it between those two limits. Okay. I also want these sections here, and right at the beginning when I said a line of symmetry, we can actually just work one of these out and just multiply by 2. So what you can do is between 0 and pi over 6 of the 3 sine theta and just times it by 2. So what we have is, I'll write it down here actually, just so you can see this. 2 times by 5r is equal to 3 sine theta. R squared becomes 9 sine squared theta. So I have 2 times by the integral, the area of that sector. So I have 1/2 times by 9 sine squared theta d theta between those two limits, 0 and pi over 6. If I go back on my graph, at the beginning is 0, it goes all the way around to pi over 6, and we can just multiply that sector by 2, and that's why I've got this 2 times here. And then we can simplify this. I end up with just one integral. When I like to do these types of questions, I just like to combine them together, you know, just so I know what I'm, you know, I just like to do it together. But you don't have to. You can do this separately, absolutely fine. but I've color coded it, so hopefully that's a bit easy to understand. But now we're going to do the actual integration. So we can't just integrate sine squared theta like this. So what we have to do, we can use our cos 2 theta identity. If you do like calculus 2, you can use your recurrence formula. If you're doing like something like further pure and you know it, definitely use that. But we're going to be using our cos 2 theta identity, which gives us 1 minus 2 sine squared theta. I'm going to rearrange for sine squared. This gives me cos squared 1 minus 2 cos squared over 2. This gives me sine squared theta. I'm going to substitute this into my original integral. So I end up with 1/2 the integral of pi over 6 5 pi over 6. And I end up with minus 1/2 cos 2 theta. So I've just separated this out. Plus 2 sine theta. And then I have a half here. A half plus 1, that's just 1.5. Okay, that's 3 over 2 d theta. And then I'm going to do the same thing here. In this case, we just have 9 sine squared theta. So that's just the same thing as 9 times by all of that. Plus the integral of 9 over 2 minus 9 over 2 cos 2 theta. I've just separated the fraction out, like so. Cool. Now this is a lot more doable. When I like to integrate, right, honestly, I'm not very good at remembering the sine cos stuff. So I just write this little thing on the side. Sine differentiates to cos, cos differentiates to minus sine, and so on. And minus cos comes back around. And then backwards is just going to be me integrating. So if I look at this integral, okay, cos 2 theta, if I go to minus cos here, minus cos will integrate to minus sine. So this goes to sine 2 theta. This will be probably a minus there. And then I'm going to divide that coefficient by the 2 from here. So that gives me minus 1/4. And then I can just double check, does this differentiate back to that? Yes, it does. I'm happy. We're going to do the same thing with this. This will go to 2 cos theta because this will go backwards to that. And this goes to 3 over 2 theta, like so. And then I have my limits as well. I'm just going to move this on the side over here. And then I'm going to do the exact same thing like so. You can probably factorize a 9 over 2 out, but I'll leave it in there. This becomes 9 over 2 theta. I want minus cos goes to minus sine, so this becomes 9 over 4 sine 2 theta. That becomes 0 and pi over 6, like so. And then I just substitute all the numbers in. Now we can substitute it right into a calculator. So what I would do, I would probably just substitute the pi over 6 in to all of that, and then do it separately with 3 over 2 pi, and 3 over 2 theta. So if I substitute all the numbers in, that gives me 1 over 2, 9 root 3 over 8, plus 3 over 2 times by 5 pi over 6. That gives me 5 over 4 pi, minus, and then we do the same thing again, but this time we're just going to use pi over 6, like so. And we end up with minus 9 root 3 over 8. And then we're just going to multiply the 3 over 2 times by pi over 6. That gives you 1/4 pi. And then we do the same thing with the other one here. So on this one, this is just 0, that's 0, so we don't have to subtract the 0 here. But 9 over 2 times by pi over 6, that gives you 3/4 pi, minus 9 over 4 sine 2 times by pi over 6. That gives you 9 root 3 over 8, like so. Okay, and then we can add everything together. So we end up with, this is going to add together with this, so we end up with 9 root 3 over 4. This subtracts with that, it's 5 pi over 4 minus pi over 4, that's just 4 pi over 4, which is just pi. And then we half it. I'll do that afterwards. There should be a pi here. Minus root 3 over 8, like so. And then we're just subtracting, so this becomes 9 well, 9 root 3 over 8 plus pi over 2 plus 3/4 pi minus 9 root 3 over 8. That becomes 3/4 pi plus 1 over 2 pi. That becomes 5 over 4 pi. And that is our final answer.